In this video, we are going to talk about Lab 4, which is about mechanics part 2, and we are going to work on statics, which is about force and equilibrium actually. This lab has two different parts, procedure part A and procedure part B, as you can see here. And what you need to do in this lab is first of all convert all forces from magnitude and angle notation into unit vector form, and then you are able to actually answer the questions. In this lab, we are going to use a vector simulation tool that we already talked about that during the lecture. And then we are going to apply vector addition to determine unknown forces and or angles. And all of them are based on equilibrium because we know that we have different equilibrium situations in this lab. And based on the equilibrium, we are trying to find the unknown values. For procedure part A, you have some simple questions that we already covered them in lecture part. There are some vectors given in I and J form. Like vector A is 3i plus 7j, vector B is 4i minus 9j. So we have four vectors here, and these four vectors in two-dimensional vectors actually are given in I and J. So you have X components and Y components of all these vectors. And there are different parts asking you to just on a paper graphically combine the vectors, like calculating A plus B plus C by just graphing them. So you are going to draw X and Y axis first, have the origin, and then you will start from the origin graphing vector A and then graphing B and then vector C. So it's going to be A plus B plus C. And then you are going to find the resultant vector, which is vector G. And then you are going to actually on paper calculate the magnitude of that resulting vector. And in question number 4 is something similar. You are going to just repeat the previous steps for finding resultant vector H, but this time H is a different one. It's like C minus A minus D. And K also is a vector A minus C plus A. And an easy way to just solve when you have subtraction is, as an example here, we have minus A. You can multiply negative to 3 and 7. So actually vector minus A is negative 3i minus 7j. And then you can assume that you have vector C plus vector negative A and then plus vector negative D. So so you are going to use like head to tail method. You can use the same thing you did in part A. So this is just a simple part for procedure for part A. So we are going to just do it on a paper graphically. And then for part B, as you can see here, there are some tables given. And for first one, what you need to do is just express each force using unit vector notation. If you look at the first row, you can see like vector 1 has specific angle given to us, and also the magnitude of that given to us. The type of vector in this lab is force, so the unit of that is newtons in SI. So as an example, vector 1 has a magnitude of 55 newtons and the angle is 0. This angle is the angle from positive x-axis. Vector 2 also is given in angle and magnitude, and vector 3 also the same. In this case, all vectors have the same magnitude but in different angles, and you are going to draw a free body diagram drawing all vectors from the origin. And all these vectors actually cancel out each other because we have an equilibrium. For question number 3 and question number 4, there are same tables, but we have an unknown value that you are going to actually find that unknown value. In order to find the unknown value, for question number 3, the unknown value is an angle for the last vector. And for question number 4, the unknown value is the magnitude of vector 3, the last vector. Again, you are going to follow the steps. for finding the unknown angle, the first step is finding all those vectors in I and J form. And after that, you are going to add all x's together equals 0, all y's together equals 0, and then you can find the unknown components actually. If you look at the lesson 4, there's a link here. If you click on it, you will see there is a lesson here, and it shows you all the steps you can do in order to find the unknown value. So set each vector's magnitude and angle. First of all, we have them. The simulator will displace the x and y components of each vector and convert each force into its vector components using the simulator, and then sum of all vectors equal to 0 in x and y direction. So this is the simulation we are going to use as we used it before for uh, questions of homework and discussion worksheet. You can see there are two sliders here. One slider changes the magnitude of the vector. The second slider changes the angle from the positive x-axis. When it's 0, the direction of the vector is in positive x-axis, and then it increases counterclockwise. So as you can see, when we are 88 or 90, it's going to be here. And then if we go more than 90, it goes to this part. So all of these angles are counted from positive x-axis. And then automatically it gives you the x and y components. If the numbers are smaller and the vector is smaller, simply you can click on these buttons like the zoom out and zoom in. So you can use these buttons to use a proper scale and see your vector in components form. So what you need to do is for each of these vectors here, use the simulation and find the components of them in X and Y. And after finding the components, you are going to just set all X components added together equals 0, all Y components added together equals 0. And then you are going to find an unknown value in that case. And at the end, when you find like the unknown vector, as an example, like X component for the third vector and Y component for the third vector, you can use Pythagorean theorem to find the magnitude of that, and also you can use the simulation again to find the angle in case you are looking for the angle. So in general, this lab has two different parts. One part, in part A, you are going to just graphically show the resultant vector. When we have these vectors, you are going to draw them and graphically find vector G, vector H, and vector K here. And for procedure part B, you are going to use the simulation, convert all vectors from magnitude angle to I and J form, unit vector form, and after that, finding the unknown values and draw a free body diagram for each part of procedure B.